Hello everyone, and thank you for joining us for our webinar today, Unreal Engine and Vectorworks for Live Events. My name is Lindsay Lee, and I'm the Marketing Specialist for the entertainment industry here at Vectorworks. Just a little housekeeping before we get started. First, this webinar is being recorded, and the on-demand version will be posted to Vectorworks University, where you could find this webinar as well as all past webinars. And after the webinar, we'll be sending out an email with the recording to everyone who registered. Lastly, if you have any questions throughout the webinar, please write them in the question box, which is located in your control panel, and we'll save some time at the end to get through them. So without further ado, I'd like to introduce our presenter for today, Patrick Wombold. Patrick is a Senior Solution Architect at Epic Games. He worked with a variety of clients across live events, broadcast, and virtual production. As an Unreal Engine expert, his work spans internal Epic properties such as Fortnite and Rocket League, in addition to large-scale events like Coachella, Tomorrowland, and the Super Bowl. So let's give Patrick a warm welcome, and we'll go ahead and get started.
Welcome everyone. I'm very excited to bring you today's topic, which is Unreal Engine and Vectorworks for live events. My name is Patrick Wombold. I'm a Senior Solution Architect at Epic Games, focused on broadcast and live events. As a little bit of background, if you don't know who Epic Games is, it's a 30-year-old company. We're in 15 countries around the world with over 4,000 employees. And we're probably best known for our first-party games like Fortnite, Rocket League, and Fall Guys. But the underlying tech behind that is a product called Unreal Engine, which powers not only games use cases, but a variety of non-games use cases as well. Things like media and entertainment, automotive, simulation, and more. In addition to that, we have an entire suite of tools to help creators get going. Things like Twinmotion, Sketchfab, MetaHuman Creator, Capture in Reality, and a variety of other tools so that everybody has a complete ecosystem of tools to build all the content that they want. Our mission is to empower everyone to create and share compelling real-time 3D content and experiences. And this is really great news because for anybody who is using it on the M&E side, it's free for creators. And this is awesome. Even on the game side, up until a certain revenue point, which is outlined in our EULA, it's free for anyone to use. Before we get any further, I just want to say special thanks to Vectorworks for allowing me to do this presentation. Shout out to the Fortnite competitive team for all their hard work on the event that I'm going to show off today. Blast was the company who executed the event in Raleigh. Lightswitch did the lighting plot, and MA Lighting definitely helped me out with any of my MA3 concerns. And lastly, I just want to give a big thanks to our MVR and GDTF volunteers. MVR and GDTF is an open protocol, and it is run entirely by a team of volunteers, so if you want to get involved, please reach out to us and we'd be happy to have any assistance that you'd be willing to give. Let's dive in a little bit on the project we're going to highlight today, which is the Fortnite Championship Invitational in Raleigh, North Carolina. It took place last year, November 12th and 13th, 2022. We had 27 different countries worth of players represented, $1 million prize pool. It was the first major live event for Fortnite esports since COVID-19. It was live on Twitch, YouTube, Facebook, and more. The plot was created by Lightswitch, which was then imported into Unreal using MVR for lighting and then Datasmith for stage geometry. The same MVR was then imported into MA3 for lighting control. We had over 700 fixtures in the plot, and there was about 20 different types of fixtures. So before we go too much further, let's talk a little bit about MVR and GDTF. I'm going to give you my definitions, and these aren't necessarily official, but this is how I look at it. So MVR, which stands for My Virtual Rig, is an interchange format that describes what lighting fixtures are used in the plot along with their patch information. It also can contain set stage prop elements, things like trussing and stage decks. GTF is a general device type format. The official definition is written down here, but really what it does is it describes what a light can do. So its physical characteristics, its lighting characteristics, its channel sets, what attributes it has, color space, etc. This is the first time we've really had kind of a unified format for either of these things that's lighting specific. And so we're really excited about this because it opens up a lot of opportunities. So the way Unreal uses this is we use the MVR for import and export. We use the GTF for fixture profiles and definitions. A couple of things to note. The current implementation is limited to GDF fixtures only. So if you create fixtures using traditional Vectorworks fixture definitions or Vision ones or other softwares that don't use GTF, we're not going to be able to read that information. We're not using all the GTF features in 5.2, but of course we're going to keep expanding that in the future. And kind of getting on board with this, we released our own GTF profile for in-display light cards, which is available on gtfshare.com. If you've never been to the website before, this is what it looks like. Once you set up a username and login, you can go and you can find our light card. There's a couple of different modes for it, and we'll keep updating it as things progress. For the rest of the presentation, these are the softwares that I'm going to use and some of the requirements for this workflow as I'm showing it today. So the demo is made using Vectorworks 2023 Service Pack 4, but MVR and GTF was actually introduced back in 2022. Unreal Engine, the demo is running a 5.2 source build, but all the features that I'm going to show are available in the launcher build, and they were also available in 5.11. And as far as GrandMA on PC, I'm running the demo 1.882, but as far as I know, almost every recent version of MA3 has these capabilities. Let's take a look at the Vectorworks plot and start poking around a little bit. I didn't actually create the plot in this case, and it was actually done by one of our vendors. It's pretty well organized compared to most likely how I would have done things in the past. And I won't say it's a simple plot, but it does have mostly straight trusses, a lot of it's symmetrical, but at the same time there was approximately 700 or so fixtures that made the cut, and these were some of the types that were used. And what's important to note about this is that when I went back to kind of retroactively add GTF and MVR support to this, I needed to have the GTF fixtures. If I don't have a GTF file at this moment, Unreal won't actually read the MVR import because that's what we use to actually construct like the channel sets and all these types of things in lieu of having a built-in fixture library. So the first thing I had to do is actually go through this list here and find them on GTF Share, and if they didn't have the one I wanted, I had to find a suitable substitution. It didn't really take too long to do this, so I'm going to go ahead and pop over to another layer and we'll start. I'll show you kind of the process that I went through. Now that we're on a normal sheet layer, the first thing I needed to do was import the GTF files. I wanted to get them into a folder in my resource browser. So in order to do this, what I had to do was go import GTF. Then I need to know the path where those files are. And then you can import them all in one batch, or you can do them one by one. It's kind of just depends on what you're doing. And then I just organize them into this folder. One of the things that has come up so far is that a lot of people, especially good designers, have a nice library of these fixtures they've already kind of built up, and they have these nice symbols and they have the legends all set up, and GTF is still an extra part of this right now. It doesn't take too long to add this in after the fact, but it does mean that you're going to have maybe 2 assets in the resource browser for each light that you want to use. So now that we have them in here, if you hadn't already done a plot, you could use fixture insertion tool and insert them and do all that. But since this already existed, all I had to do was actually attach it to them. So I knew this one was a Viper, and if I scroll down a little bit here on the right, I can see where I would add this GTF fixture mode, and that's where I would actually pick this. So if one didn't exist already, I would go to Other, and it's going to give me a little pop-up window, and from there I'm going to pick what it is that I want to have it be. So I would pick this performance extended mode, and then I would hit OK and everything would be good. So doing this obviously one by one with fixtures would take quite a long time. First I tried the select similar, but that actually selects all lighting devices. So if you right click on it and do select devices by instrument type, that would quickly grab all of them. And then I would be able to do this in one go, where I could just go down here, pick my fixture mode, and it would apply it to all of them that were of that type. And since there was only about 20 types, it really didn't take that long to do this. And that's what I needed to get the GTF information attached to each of the lights. A couple other considerations with this workflow. In order to attach a GTF profile to this, it needs to be a lighting device. If you were used to using symbols only, you would have to convert them into lighting devices first, and then you'd be able to add a GTF fixture mode. When you go to export, it's only going to take into account visible layers, which is super handy, especially if it's organized well and you can quickly screen what it is that you do and don't want to export. When I go to export the MVR file, I actually even get more screening options here. So I can say, do I want to do visible objects? And then even within those, I could just turn all these off and decide I only want to export lighting devices. This will show a list of the GTFs that are going to be encapsulated in the MVR file format, and then I can also decide if I want to use 3DS format, which is the legacy model format.
From here, I could hit OK and export it, and everything would be good to go on the MVR side, and that would contain all of my lighting data that I would want. Now, I mentioned before that we're going to use two different types of file formats to get everything out of Vectorworks. Since Unreal does not use any of the scene geometry or prop geometry, to get that stuff out, like the stage decking and any of the trusses and things like this, I'm actually going to use the Datasmith format. So I go Export, Unreal Datasmith, and then I get a few less options here, mostly just a quality setting. If I hit OK, then it's going to ask me where I want it to go, and if I hit Save, then it's going to export those things. And both of those elements together are what we're going to use when we go to import into Unreal, and that way we can get the combination of both the lighting data and the stage and set geometry in the same import process. A couple more key thoughts when exporting from Vectorworks. Any of the GDTF files are going to have geometry for the light inside of them that's pretty well optimized and should run well in visualizers and game engines. This is because they know what the purpose is, and they're not going to include a bunch of polygons or materials when ultimately the light itself really isn't important as much as it is the beam that we're actually going to see. For the rest of the geometry that's inside the scene when we're using Datasmith export, this is definitely not going to be the case depending on how the assets were created. In many cases, I'm not the one who created the set geometry, and so I have no idea how it was constructed. Vectorworks at the end of the day is drafting software, so its primary purpose is to create highly accurate drawings that can be then used to fabricate, do structural load calculations, and determine exact placement of things. This is a very different goal than when you're trying to run something inside a visualizer or a game engine. So if you were to just take the entire set and try and export it at one time, you're probably going to end up with a very large file that's going to have lots of nested parts, lots of materials, and things that might need to be merged together. I'm going to show this a little bit later when I open up Unreal, but I just want everyone to keep that in mind, that when you're exporting, it's a really good idea to use layers and export things out in logical groups. So I would probably do like one export for the set, one export for trussing, one export for miscellaneous items, and you can break it up as finely as you want. It honestly doesn't really hurt, but it will be much more efficient to load in like several small pieces than one giant Datasmith file. And again, if you are the kind of person who works in Vectorworks all the time, you probably already know this whenever you've tried to translate it into other things like Cinema 4D or things like this. Like, you'll get a lot of nested parts, and the more you can merge things together, the more you can keep that like object count down, the better off you're going to be in any scenario. So we talked a little bit about the software requirements for Vectorworks and MA and Unreal. So let's talk about some of the other settings that we need to address inside of Unreal, which firstly is enabling the DMX plugin. So these are the 4 that we're going to need for this particular presentation. There are more. So for this one, we need DMX engine, DMX protocol. Those are what actually run the underlying subsystems. The DMX fixtures are what we're actually going to be using when we import the MVR, and then we have this Datasmith MVR importer, which allows us to import these MVR types with our Datasmith importer. There are other plugins though that use DMX and that also use some other control protocols. So DMX display cluster is if you're using NDisplay and you need perfect sync between the nodes, you would use this. Pixel mapping is just what it sounds like. And then we have a suite of kind of remote API, which is allowing users to expose certain parameters of any actor or material or whatever it is in Unreal, and you can use this with DMX MIDI or OSC or our web interface, or you can write your own protocol if you're so inclined. Let's take a little look at the final product before we move on to importing. This is what the scene looked like after I came in and just added a few textures. I'm actually not using any of the advanced rendering features of Unreal. This is just kind of the raw deferred renderer. And I just applied some materials from Quixel Bridge. I put a couple of decals and some stuff up at the tape line. Somebody left a cable sitting out. And this is just some of the stuff that you can kind of do inside of Unreal when you're taking advantage of all the 3D tools and stuff that we have to offer. One that I wanted to highlight really quickly, as I mentioned a second there, was Quixel Bridge. Bridge is a really awesome addition to our tool set where you can get access to all these textures, decals, surfaces, etc. So let's just say I wanted to go and add in another decal, and I've already downloaded this torn poster, so it's ready to go, but otherwise I can just click download. I'm going to click add to add it to my project, and then bang, I already have this material in the project ready to go. So if I wanted to say apply it to this wall in a different spot, I've already got a decal up here, so I'm just going to duplicate that one and move it down, and then I'm going to apply this texture to it, and there we go. So now I have this torn poster that I can also apply to other sections. And that's how easy it is to kind of go through and add some additional detail to some of these projects that might just add that extra layer of either realism or believability, or just to have a little bit of fun while you're working on some of your projects. What we're going to do next is dive into some of the DMX settings, what kind of things we're going to be trying to import using MVR and Datasmith, and then we'll come back to this and hook up some live DMX with the Grand MA3. Now, before we get into actually importing the MVR and Datasmith scenes, I'm going to go over a couple of settings in Unreal that you're going to want to pay attention to when setting up a project to use DMX. Specifically, I'm talking about the project settings. So if you go into your project settings under plugins and then DMX, you'll have this section which we call DMX ports. And DMX ports are something that define the input and output, the physical networking infrastructure that you're using to get DMX in and out of your project. So I already have my input port set up, and we similarly have output ports, but if I wanted to create a new one, I could just create a new port by clicking that button. I'll then get the option to name it, so I can name it port 2. You can pick ArtNet or SACN, so in this case I'm using ArtNet, so I can leave it alone. And then you can either pick the network card discretely, 0000, we'll pick the default one, or you can use the autocomplete feature, which will figure out which NIC best matches what you give it. So if I give it 192, I get this, and if I give it 10.star, then I'll get that. And that's how that will work. And then you define your local start, the amount of universes, and then external start if you wanted to remap it somewhere. Also in here we have some default settings that are kind of important. So your send rate, whether or not you should send or receive by default, and whether or not all patches should receive in the editor. As of 5.1, you no longer need to be in play mode in order to receive DMX. So this is a really handy feature to have. We also have the default fixture categories and attributes. These are less important now because attributes are created on the fly when libraries are created. But these are the default ones that come with the engine. So if you wanted to add some to your project, you can add as many as you want in there. And these are the general settings that you'll need for your DMX ports to be able to receive and send DMX from the engine. We also have this little bar up here at the top that will give you access to a channel monitor, an activity monitor, the patch tool, and new as of 5.2, an update to what we used to call the output console is now the control console. Right now I don't need these specifically, but you can also disable or enable DMX on more of a global level if you need to turn it off for things like take recording or different scenarios. And so once we go to import this MVR, we'll show you a little bit how the ports play into the DMX library. In order to better show what's happening when we import things using MVR and Datasmith, I've created a new blank level in which I'm going to show kind of the process that we use. As I mentioned previously, there's two different file types that we're using when we export from Vectorworks. We have the MVR file, which actually contains all the lighting data, the fixture data, and it contains the GUTFs themselves, as well as if you had included props and other scene elements. And then we have the Datasmith file. So for Unreal purposes, MVR is not going to import any kind of props or scene objects. It's only going to deal with lighting data. But Vectorworks also already has support for a UDatasmith format, so that's why we have this UDatasmith file, and then the assets that kind of go with it. So these are the textures and any of the mesh data already ready for Unreal import. So there's a few different ways we can tackle this. If we only want the MVR data itself, we can just drag that into the content browser directly, and then I'm going to get a pop-up window that looks like this, and it's going to ask me a few options. If you're in a previous version of Unreal, you might get a warning about incompatible MVR versions. It's totally okay to ignore that. There's not that much that changed. So what we're going to try and do here for you is, if you hadn't set up any ports, we're just going to create one that covers the entire universe span. But I've already done this, so I'm not going to try and update any of the ports. I want to create a new DMX library, but if I already had one in here, we could also just overwrite it and replace it. And this is going to ask if we want to re-import GUTFs. It's only going to check in the local directory to see, so it kind of depends on where you put it. So in this case, I'm just going to click import, and it's going to think about it for, I don't know, a couple of seconds here. And then we're going to end up with a DMX library and all of the imported GDTFs that go along with that library. So DMX library inside of Unreal is somewhat of the container for the patch and data information that we want to access. So we're going to dive into that a little bit separately, but now I'm going to go back and show what would happen if we do this with Datasmith files as well. So now we're going to take a look at how we would work with the Datasmith file along with the MVR file. So I've removed the library I imported previously, and now I'm going to import them both at the same time. So in order to do this, the naming is important. It needs to be matched identically, and they need to be in the same folder. You don't have to do it this way. There's nothing that prevents you from just importing the MVR by itself and then doing the Datasmith files separately. But if you wanted to do it all at once, we do kind of provide a nice option for that. So I'll show how that should work. And again, the Datasmith file contains all of like the prop and scene data. So what I did this time is I'm only using the video assets. So the video surfaces, and then there's some cameras in there. And the reason I did this is because if I do one giant Datasmith import, I'm going to get a ton of geometry. It's going to take a while to show, and I don't really want to slow down this process. But it's also just something I do generally anyhow, is that I'll break it up into chunks. So maybe I'll do like the stage decking, the trussing, things like this. I'll make them separate Datasmith files and just import them one at a time. That way I can kind of optimize and do things as I need to, and I'm not forced to do it for a gigantic import. So in order to do this, what I'm going to do is go here, I'll go to Datasmith file import, then I'm going to pick the Datasmith file, and I hit open. I'm going to get a series of options. So first it's going to ask where I want to put it. So I'm going to put it inside test import folder, and it's going to create a new folder inside of that to contain the Datasmith assets. So I'll hit OK there. Another important thing to note is that when I do this, it's going to automatically insert it into the level. So make sure you either are in a level that you want to use it with, or you've created a new sublevel that then you're going to add to something else, so you don't end up with 10,000 new items that you weren't prepared for. So I'll hit OK. Now I'm going to get Datasmith import options. So I'm going to just take geometry, materials, and textures. Ignore any lights, cameras, or animation. I'm not going to generate light map UVs because it just takes longer, but normally I would do this if that way I can bake out if I want. And then we want to have this import MVR checked. This is what will actually tell Unreal to look for the MVR file in the same directory. So I'll hit import, and lastly I'll get that MVR import options again. So don't need to mess with ports, don't want to re-import GTFs, and I will create a new library. So once I hit import, it's going to think about it for a second here. I get a little progress bar. I think you can only see part of it due to my widescreen monitor. And as soon as it finishes here, we'll take a look at what happens in the scene. So it usually only takes a few seconds for these kinds of file sizes. So here we are. So we have the MVR scene actor as well as a video actor. So there's a video surface in here that has a texture on it that I'm not 100% sure that I'm able to show. So really quick, I'm going to change it out for, there's like a checker material here. And now I can take a look at this stuff. So what I have now is, like I said, I have the video meshes as part of that Datasmith actor. So if I go up to the top here, shift click, it'll collapse everything. So I get all the video option, chunks. So I have video services, there's some platforms and cameras, and then I have all the MVR data, which is all the lighting data. And so it labels them and generates it based on what it was named. So down in the actual content browser, I have here the Datasmith scene, all the textures, materials, and geometries. And when I use this import method, it actually sticks the library in the root content folder. So in order to just kind of keep it a little tidier, I'm going to put it back in this test imports folder here. And so that way I have the library kind of next to the Datasmith stuff. And so now what we'll do is we'll dive in a little bit more into the library and how the MVR scene actor work and how you can kind of replace these lights and do things with them. Really quickly, we'll go over kind of how the library works and what the structure is like in Unreal. So if I double click the library, I'm going to get a new window that gives me all the information about the patch and all the fixtures and everything that we have in here. There's a pretty good search thing, so if I know what I'm looking for, if I just type in fixture IDs, it's going to it's a little bit smart. It's going to try and find what I'm looking for, and this will tell you kind of some of your options you can search by. universe is, patch name. So if I was like, give me all the Vipers, it's going to try and do that. So it's pretty decent. You can change the colors and you can change the patching and everything from this screen. This is also where you would pick what kind of ports you want to use. So I could say, I'm not doing output, I only want to do input. And this is the fixture types that have been imported. So these are the GTF files. They come in, they automatically generate fixture types, and they're linked to the GTF that we used. And then again, it generates this list of attributes that we can use and kind of gets a little bit of the default information from it. And this is generally the library. But something that might not be obvious is you could also import and export MBR from this screen. So if you had a library that existed already and you just wanted to import over it, you could do that. Or if I created a library or made edits here inside of Unreal, I can export the library. Now, something really important to mention here though is if I go in here and just create a fixture type using this dialog here, this one's not going to export. We don't export GTF compliant fixtures yet. So if you were to just create like a simple RGB fixture or something like that, it's not going to export. So when you're using this workflow, you really want to make sure you have GTFs for everything that you're doing. That way you can kind of import and export effectively. So if I wanted to take this, make a couple little changes to the patch, export it again over to MA, I totally have the ability to do that. Or vice versa, if they wanted to make some changes, I could import it back in here as well. So next we'll take a look at the MBR scene actor. Let's take a deeper look at this MBR scene actor, because the MBR scene actor is the link between the DMX library and the objects that are being used in the scene as our fixtures. Unlike maybe traditional lighting where there's a one-to-one relationship where if you have something in the patch, there's an object that's associated with it, Unreal is much more generalized. And so you can have multiple libraries, which would represent, a show file. You can have fixtures that aren't assigned to anything or that are assigned to multiple libraries. So it's pretty infinitely flexible, but at the same time slightly different. So this scene actor is that link, and so it says if we want to use this chorus line, use this fixture type to represent it. Since we don't have a fixture library of ourselves that we maintain, it's just these kind of generic placeholder styles that it's going to try and choose from. A couple of things you can do with this is, so if let's just say I moved this one and I deleted this actor, I can go back to this MBR scene actor and respawn deleted and update transforms to get us back to where we were. This will apply to the entire library, so kind of use with caution if you've already made some edits that maybe you don't want to undo. So it does a decent job of trying to match as best it can, but I know for a fact this is not what a chorus line looks like, right? It's more of a blocky bar fixture. So we're going to go ahead and substitute that back out. So instead I'll pick the static matrix, which is going to give me kind of this square looking thing. I can also hit select here and it will select all of them, so I could make adjustments to, like, say the light intensity, or in this case I'm going to change the width and height so that it looks a little bit more like a bar. I'm going to then flip these around to make them look kind of a little bit more correct. So I could say minus 180 and that'll get me here, and so now I have kind of a similar thing. But if I wanted them to splay really nicely, I'm at 262, so we'd say minus 38 here, and then these I want to go minus 8, minus 45, and there we go. So now I've got this kind of nice V shape that kind of matches with what the original intent was. So this is really, really handy to be able to kind of do this and make these kinds of changes. But let's say you had a fixture that you had made on your own and you want that to appear in this list. What's going to make that happen is two things. You need a DMX component, and then you also need the MBR interface implemented. So if I look at the blueprint for the wash LED, you can see we have a DMX component and we have this MBR interface that we're using. And it's automatically inherited here, but so if you've made your own, you would need to add these. So we'd add our DMX component, search for that, that's good. And then to implement the interface, we need to go to the class settings, and then add an implemented interface. We'll search for the MBR, we'll add that. And now if I compile and save this, if I go back out to the level here, and let's say I wanted to change it, now I see this BP underscore new fixture, which is going to represent the fixture that I've created. So this is a way that you can substitute in other fixture types that maybe you've done, or if you've made specific edits, you can do it this way. And this is really, really handy to be able to kind of make these global changes and kind of set things up the way you would anticipate using the fixture types that we kind of have in this case. One last topic before we move back to the completed project to poke at it and hook up DMX from the MA is this idea of kind of optimizing. Because when you import objects from other software, they're not necessarily designed with 60 FPS and game engines in mind. And so you're going to get maybe a lot of parts that have lots of kind of nulls and references and things like that. So for example, if I have this stage deck, right, that is it's comprised of all these pieces. So if I know that I'm looking for this 206 instance, let's just say. If I do Control-Shift-D, it's going to select all the descendants. And really, I might want all this as one thing. So we have a nice kind of tool for that inside of Unreal. If we go to Actor, Merge Actors, I'm going to bring up the Merge Settings dialog. And it's going to say, what do you want to do? So it looks through here and determines, all right, there's this many static meshes. We're going to merge them all together. We can have it generate light maps. We can pick other things. But this is I don't believe checked by default, so if I want to replace it in place with my new actor, I would choose this one. And then this is going to do it. So if I hit merge, then it's going to ask where do you want to put it, because it's creating a new asset for me. So I'll put it inside this merge test folder. If I hit save, and bang, it's already done. And so now I have this one deck, which is representing what used to be 6 separate meshes, and it has the materials assigned. The one thing it doesn't do, though, is remove all those null references and transforms. So if I wanted to get rid of those, I need to go back, select all of those, and then delete them, and then that would totally get rid of any of the additional references that were still in there. And this is one way to kind of go through and optimize and get your scene ready to go. I actually merge giant groups of things together usually if I know I'm not going to move them independently. So I'll put like the whole stage or all the trussing or anything that's I know is not really going to move. I might just lock those together because having lots of objects in here will make Unreal run a lot slower. Lots of polygons, no problem, but lots of individual objects are not quite as friendly. Now let's dive into the MA3 console and see how this MVR import works and how this works together in the ecosystem. So in order to show this, I've started a blank show in the MA3 on PC, and I've copied that same library that I made separately, the _ISO one, into the MA Lighting Technology, Grand MA3 Library, MVR folder. And it's from in here that we'll be able to access it when we go to patch. So I'm not going to go through a whole lot more on this. I mean, I did set up my protocols and my network, so all that's good. I know it's working. And now we'll go into the patch screen. So I don't need to actually add any fixtures since they're all going to be contained within the MVR. So I'm going to go and select Import MVR. I'm going to pick this ISO one and hit Import. And it's going to sit and kind of generate the scene objects. It actually does this fairly quickly. I mean, considering how much geometry is in there, I think it doesn't take that long to do. So hopefully, and I think it starts to go faster depending on what's happening. Excellent. So we sped that up a little bit, but now it's basically asking, okay, what do we want to do? Do we want to take all of this stuff, or if we were trying to merge, this is where we would set up our merge settings. So there's nothing in there, so I'm just going to hit import MBR, and then it's going to have to, it kind of like preloads all of them, and then so you get a look, and then this is where it's actually writing them into the show file, from what I understand. Excellent. Okay, now that all that's done, we can see we have all of our fixtures, but we also have all these extra parts here that represent different kind of groupings and stuff. This is something new in MA that has kind of come up, that you can do this kind of stuff. But everything in here, everything's patched, and hopefully everything's good to go. So if we save and exit, now we have everything that's in there. If we pop into the 3D view, and again, just kind of move around here, now we can see what it is that we've got. And so this is just the lighting data, of course, like so, but this is what we had. So then I'll go ahead and load up the other show file that I made, where I've already made a couple little groups, and I've done all that DMX output mapping, and we'll take a look at that. Okay, and so now we're back in the original show file I made for the demo I did at LDI, and I hate to say it, but after all that work, this is kind of the easy part. So in this show file, I knew I was using it on PC setup with a 2-port node, so I just kind of granted universes in a kind of symmetrical way so I could make at least one look for the stage. But with a full-size console, I think I could control everything. So in the background here, I have the Unreal scene, the one that I'd already textured and did everything for it. And at this point now, I just made, again, like a simple preset. And if I go back over to Unreal, here we are. So we can see that, we're getting input on the universes that I want. I can check in the activity monitor and, and just verify that this is, in fact, the correct stuff that I'm getting. And then at this point, it's just kind of up to the lighting programmer to do what they would normally do. Some other things that maybe to think about in this workflow, if I go back to MA and go to the 3D view in this wide angle, you can kind of see what they're giving me. So I believe I had these Sharpies selected, and MA3 will show it to me, but it's not actually outputting. But one thing that did happen right away was these ones that were on the wall. They were inverted, and so to I hate to say fix that, but to mitigate that, I actually just went through and put a 180 on the Z location of it, because I think the way MA does it is they actually try to read like what is the fixture's default orientation. Unreal just always uses like a 0. So it might be that some things are flipped or some fixtures, start at 90, and so there still might be some of this stuff to work out. But in general, this is kind of the effect that I was going for, and so we're getting at least mostly congruent data between the two applications. And this is really cool to be able to have one show file concept that started in Vectorworks, was exported and then brought into Unreal and MA, and then we kind of work in a continuous workflow this way. So this is just live in the editor. Like I said, we don't need to be in play mode anymore to do this kind of stuff. However, it does probably run a little smoother. Something else that you can do is if you wanted to record this, and so you could then render these out later with better settings. Like right now I have just pretty much default rendering settings in Unreal. Nothing too crazy has been enabled. But so I can add here, if I go to add source, I can pick DMX library, and by default it doesn't know which one I want, so I'm using this FNCS V6 one, and I could say I want to add all the patches, and so it's going to add all 719 fixture patches. So I could then record this data and play it back. There's a checkbox here to record normalized values, and it kind of tells you what it does, but essentially this will normalize everything 0 to 1 rather than using 8-bit or 16-bit. And there's pros and cons to both of these methods. I mean, one is the raw data, and the other one is if, hey, later on maybe I wanted to translate from one type to another, or I wanted to have smoother curves, like normalized values can maybe get me there quicker, and I'm not having to do byte integer conversion later on. But yeah, so this is, like I said, probably the easy part where you just kind of are like, all right, we're ready to go, and now you can let the rest of the team do their stuff. So what I'm going to do next is go over just kind of a few other considerations if you're considering doing this workflow, some areas that we know have limitations, and then kind of where we're headed for the future. Let's go over a few more overarching workflow considerations when working with MBR, because there's a lot of things about this that are different in the past. In the past, you would have maybe a situation where once the lighting plot was created, it was given out to different departments, and they all kind of work in isolation. But now, the source of truth can be distributed, and everybody can kind of work on the same file format. So proper organization is still going to be the key to success here. Things like file management, how you name things, are going to maybe require a little bit of study and trial and error to figure out what works best for you. Because if you're trying to re-import things, like a lot of times you want to have some sort of a record of what you did, or change lists, or versioning, something like this, which may or may not always work with every piece of software. MA has a really good way of dealing with it, I think, with their kind of partial show read-esque format, where you can determine, okay, here's the things I'd like to merge in, and here's the things I won't. But again, would you immediately save that as a new show file, or how does your show file need to reconcile exactly with the MBR version. Stuff like this is stuff that I think I haven't done enough kind of thought process on, but something just to keep in mind. Some other things that are probably going to come up, fixtures that don't have GTF profiles. If you run into this, there's obviously a GTF builder. You can make it on your own, but I'd really encourage reaching out to the manufacturer and asking, hey, can you do this? I feel like a lot of them are doing it for new fixtures, but maybe not some of their legacy fixtures that are still out there. Other parts of the pipeline might not support these formats, right? So if you're trying to go into like a CAD software, they might not have that. And there could be other portions of larger workflows that maybe don't include these file formats yet. But that doesn't mean that they can't in the future. It's a fairly simple protocol and set of rules that MBR has, and I think it could be easily implemented by other software platforms. One thing that I did notice in some other programs was that custom attribute names might not be fully supported. So a lot of times the attributes of a light, kind of already been predefined, whether it's dimmer, pan, tilt, color, stuff like this. So if for something more complex, like the one that we did with the light cards, a lot of things didn't exist, like there's no alpha channel, right? Or something like that might not be something that has been defined by a lighting console. And so you may need to reconcile those against known attribute names. And the last thing is the optimization of non-lighting geometry. I haven't done extensive testing in any other visualizers to find out how they deal with these large amounts of data, and I don't really know, even on an MA side, if I have a gigantic scene file, like how does that affect performance on the console. I'm sure those guys are pretty smart and they're already thinking of these things on their own, but it might just be something in my mind that I would want to check, and obviously just try and keep things within tolerable limits. And in order to not send people down a rabbit hole, I'd like to discuss a couple known limitations as of Unreal 5.2. I've mentioned many of these as we've gone through it, but just to kind of summarize, non-lighting geometry, meaning something that's not a lighting device, is not supported in the MVR file format. We're using Datasmith to do that when coming from Vectorworks, but Datasmith may not be supported on all other platforms. A lot of the other CAD software, Revit, SketchUp, all these things, they're also going to have Datasmith options, but depending on what you're doing, you may run into a piece of software that can't handle that, so you might need to stick a second MVR that maybe has stage data or something like that. Certain fixture types and modes aren't supported by our GTF importer. In general, we try to warn you, like if we run into a mode that we don't understand, we'll tell you that, hey, we can't represent this. I feel like most use cases, everything tends to work, but there's definitely some strange fixture types out there that have like nested types of things where they have like dimmer channels that are nested underneath like other types of things, and maybe we don't understand what it is, so we try our best to notify the user. We don't import fixture geometry, colors, or gobos automatically. All these things can be added, and you can kind of customize fixtures until your heart's content, but by default they're not automatically done. Unreal doesn't have a built-in fixture library, and truthfully we're not really planning on doing this. This is where in our head GTF kind of fills this void for us, that we should be able to construct fixtures inside of Unreal based on this data if this data is good. And so we're going to kind of continue to push down on that. Re-import is something that I'm actually doing some research on right now, like what is the best workflow for this? Is it kind of this partial show merging idea? Is it better to just automatically version up and replace? So this is something that may or may not always give you the desired result. And last on the list is Mac support. Most of these things are going to work on a Mac. It's just down to whether or not the networking structure is correct. And a lot of the advanced rendering features inside of Unreal don't necessarily translate. So just keep that in mind. If you're trying to work on that platform, your Lumen, your Nanite, some of these features may not actually work as desired. So PC is by far definitely the most used and recommended platform for Unreal. So with those known limitations also comes some opportunities. So here are some of the things that are on our roadmap for the future to try and close some of these gaps. Number one on that list is that DMX libraries are going to be GDTF MBR compliant, meaning that when you import a library into Unreal, and then if you were to create fixtures in Unreal and add them to your patch, you would be able to export the MBR, and it would have a GDTF file associated with it so that you can work kind of between programs much more easily. Part of that process also is we're going to try and create a system that will spawn better fixtures, so rather than just matching them against something we have, actually attempt to kind of create a better representation. So we'll use the geometry, we'll use the gobos, we'll use the color wheel, stuff like that. Again, it is never going to be 100% bullseye because lighting manufacturers are very creative and they come up with new ideas all the time that we just can't predict, how it's going to work. But that's one of the good things about Unreal is it's open source, so you can customize it to your heart's content. There's third-party fixture libraries out there like Carbon that also kind of fill this gap. But we do want to do a better job for at least the basic use cases that are out there. And along with that is the kind of prop and scene object support for MBR. In the past, 3DS was the 3D format for all of this data. And it's somewhat of a legacy format that we didn't have in Unreal natively, so we didn't want to spend a ton of time on it. But now that it's GLB, GLTF, we already have some support for that, so this should be relatively easy to add in, so you don't need to have this mixed Datasmith MBR workflow in the future. A couple of other things are control console and color management. In the past, we had this thing called output console, which was just like a list of faders, and it was really difficult to tell what you were doing. Control console is a slightly better version of this where it can actually read the DMX library and create faders that are named and have proper ranges and things like this based on what the fixture data tells us. This by no means will replace a console for any type of advanced tasks, but it should at least make testing, input-output, and kind of, this type of stuff much easier to deal with. And on the color management side, a lot of this has to do with just matching color spaces. Whether or not a light tells you it has a color space or not, it does. There's a certain range that it can reproduce, and trying to match colors between lights, a lot of times was just up to the board op or the LD to sort that out. But we should be able to do this much more programmatically and exactly if we're able to read what the color data should be, and then we can kind of create like working color space and do transforms between these things. Related to that is HDR scene color support, so we can read what the scene color is and actually get a really accurate level measurement of what the output of a light should be. And then it kind of wrapped up in that is open color IO, so that we can do these transforms using known and supported open color systems. So these are things to keep a lookout for in some of our future releases. A couple of key additional resources, number one being the Unreal Engine documentation. This is my first go-to whenever I'm trying to find answers about a particular topic. Next would be the Epic Games developer community. This is where we kind of merge together the forum and some of our tutorial videos, and users can actually create their own tutorials as well. And it's a really great place for knowledge sharing. There's a lot of stuff on there. I post on there that doesn't end up in other places. GDTF share, of course, if you're looking for GDTF, if you're looking for documentation about that, MBR. And then lastly, Vectorworks support. These guys do a really great job as well. They've got tons of webinars, they've got the forum, they've got other learning opportunities. So if you're looking for support on that side of it, that would be the best place to go. And finally, thank you. I want to say thank you to the Vectorworks team, Fortnite team for letting me show some of this stuff, MA Lighting for their support. There were a lot of people that I tapped for resources and information, trying to make sure that I was presenting the most accurate information that I could. So thank you to everybody there. Thank you to everybody who's watching. I'm looking forward to hearing your experiences, your questions, thoughts on this. And then also wanted to remind everybody that this only works because it's community driven. GDTF and MBR is a volunteer group. It's an open protocol format, so to speak, and it really only works when all of us are kind of working on it together. So it's one of the first times we've had something like this where we can interchange between any piece of software using a common language, and so we're really excited for this and want to continue to support it in the future.